Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is palindromic substrings. So we are given with a string S. We have to return the number of palindromic substrings in it. So a string is a palindrome when it reads the same backward as forward. A substring is a contiguous sequence of characters within the string. So let's see an example to understand the question properly. Like suppose we are given with a string ABC, so the number of three palindromic substrings are A, B and C. For this triple A, there are six palindromic substrings like A, and then the second A, third A, and then the first two A or the last two A. So the only important thing that the substring it's a substring, so it has to be contiguous sequence of characters. So let's see how we can solve this problem, or what is the idea behind solving this problem. So we'll use expand around center algorithm. So if we have a string of odd length, right, what we can observe that if the string is a palindrome, it is mirrored around the center. So this string AABAA is mirrored around the center character, that is B, right? So the palindrome can be expanded from the center, i.e. we can move towards the left and the right direction, including each character from the left and the right and matching those characters, and if they match, we'll shift to the another characters on the left and the right direction, and we'll keep on matching the characters until we reach the end of the string or the start of the string for the left and the right respectively. And for the even length string, the mirror lies between the center two characters, so we will expand on the left and right from the two center characters for the even length string, right? So for odd, we will expand from I, and for even we will expand from I and I plus 1, like including the two characters. So let's see an example to better understand the expand around center concept. So for each index, we'll expand for considering odd lengths and even length substrings. So for I equal to 0, we are at index 0, that is the first character. So for the first character is A at index 0, so A is also a palindrome, so we will increment the count from 0 to 1. Now we will expand from A. So on the left there is no character, so we'll stop. Now we will expand for even length substring, so we'll consider the first two characters, like the character at index 0 and 0 plus 1, that is 1. Now AA is also a palindrome, so we'll increment the count to 2. Now we'll expand from AA, so as on the left side of AA there are no characters, so we'll stop. Now we will go to I equal to 1. So for I equal to 1, we are at the character A, right? Now A is again a palindrome, so we'll increment the counter to 3. Now we'll expand on left and right. So on the left the character is A, on the right the character is B, so the A and B do not match, we'll stop. Now we will expand for even length substring considering the index 1 and 2. Now the substring AB is not a palindrome, so we'll break. Now we will switch to I equal to 2. So I equal to 2, the character is B, so we'll increment the counter to 4, as B is also a substring, as B is also a palindrome. Now we will consider for even length substring, that is BB. So as BB is a palindrome, so we'll increment the counter to 5. Now from BB we'll expand on left and right. So on left the first character is A, right? The next character is A, and on the right the next character is A, again A, so the characters match. Now we'll increment the counter to 6. Now again on right the character is A, the next character is A, and on the left the character is A, so we'll increment the counter to 7. Now as we have reached the limit of the string, as there are no characters on the left and right, so we'll stop. Now for I equal to 3, we are at in a character B, so B is also a palindrome, so we'll increment the counter to 8. Now we will expand on left and right, so on the left the next character is B, and on the right the next character is A, so B and A do not match, so we'll break. Now we will start with the even length substring, that is BA, the index 3 and 4. Now as B and A do not match, so we'll stop. So for I equal to 4, we are at character A, so A is also a palindrome, so we'll increment the counter to 9. So we'll expand on right and left. So when we expand from A or the index 4, the next character on the left is B and on the right is A, so they do not match, so we'll break. Now we will expand for even length considering the I and I plus 1, so we are at 4 and we will include 5 as well. So AA is a palindrome, so we'll increment the counter to 10. Now on the right side there are no characters, so when we expand from AA, on the right there are no characters, so we'll break. Now we will start, we will at I equal to 5, the last character, so A is also a palindrome, so we'll increment the counter to 11. Right, there is no next character to A, so that's the end of it, and the total palindromes are 11. So let's see the code part for it. So I've written the code in Java language. So I've defined a class solution and a function count substrings that takes the input s. First we will check the length of the string. If it is less than 2, we'll return 1. I've initialized a count variable that is equal to 0. Now this for loop is for iterating each character of the substring. So we'll start with each index starting from 0 till the length, till I is smaller than the s dot length, and we will expand around the center for odd substring. So we'll pass in the expand around center the string and I comma I, right, which is for odd length substring, and the next method expand around center taking the string comma I plus 1. So here are the differences, like for the odd length we will pass I comma I, and for even length we will pass I comma I plus 1. So now let's see the expand around center method. So expand around center method takes 3 parameters, that is string s, start pointer and end pointer. We'll initialize a count variable equal to 0, and this while loop corresponds to the expansion from the current I and j. So we will expand till I is greater than or equal to 0 and j is less than s dot length, and the character at index I and character at index j should match. So if these 3 conditions match, we'll increment the count, means it's a palindrome, the substring is a palindrome, and we'll decrement, we'll go on the left side, so we'll decrement the I pointer, and we'll for the right side we'll increment the j pointer. So as we did in our example, at each index we moved both right and left, right? So for example, for this BB we moved on right and left both, right, till the I for the left part it's greater than or equal to 0, and for the right part j is less than the length of the string. We are not out of index, and the each character has to match when we expand, so that it's a palindrome. And once the while loop is over or the condition do not match, we'll break out of this loop and will return the count. And in the main for loop we'll have our count as a variable, so we'll add into the count for both the expansions, for the odd and the even, and we'll return the final count once the for loop is over for each index. So let's run this solution. So yeah, test cases are accepted, so it means the solution is working fine. So let's talk about the time and space complexity for this algorithm. So as we are iterating over each index of the string, so the time complexity for this for loop will be big O of n, where n is the size of the string, and for each index we are expanding, right, for odd and even length. So in the worst case, this while loop can run for big O of n, right, where n is the length of the string, right? So we might have to expand, right? In the worst case, we have to expand for each character of the string on the right and the left direction. So the total time complexity will be big O of n square. And for the space complexity, as we are not using any auxiliary space, so the space complexity will be big O of 1. I hope you like this video, and if you enjoyed this video, please share and subscribe. It will keep me motivated to bring more such concepts of algorithm, data structure and algorithm by solving more Leetcode problems. Thanks for watching. Bye.